Hello everyone. Develop green buildings and constantly promote green and low-carbon development. Promote harmony between man and nature. Prefabricated buildings actively respond to the National Green Building Development Strategy. In such an era background, we should keep up with the pace of the times. Please follow me to open the door of prefabricated learning. Let's learn the job simulation process of cast-in-place connection of 1+X. Prefabricated components, production and installation subjects. Today's video is explained by a teacher from Langfang Zhang, Construction Industrialization Innovation Research Center.
Hello everyone. Let's go to the third part of the construction module. Cast-in-place connection. Click Cast-in-place connection. Confirm to start answering the question. After we enter the cast-in-place module, you can see that our cast-in-place operation interface is basically the same as our two interfaces of hoisting and construction. On our left, we still have our plan selection, construction, preparation, proceed options. Then, the right side is still the stacking area for tools and the stacking area for raw materials. We will officially enter the cast-in-place construction. Before construction, we will do the pre-construction preparations. Click on the construction preparation, select the corresponding labor protection tooling. After the selection is completed, confirm the wearing, and after it is completed, we make plan selection. Click Plan Selection. Select the corresponding plan. Click OK to begin. After we have selected the plan, open the current progress. It can be seen that the process flowchart of our cast-in-place module has already appeared. We can perform corresponding operations according to the process flow. Our new module, industrial process or surface treatment of the interface. Steel processing, cracks in processing, and then the steel bar. Connection measuring lines, template processing. Formwork, installation, concrete pouring, concrete vibrating, watering maintenance. Among them, we combine surface treatment, reinforcement treatment, and wall joint treatment. Is a 3 coordinate relations. The 3 tools, which one started, is up to you. But I will give you a suggestion here. When we have 3 parallel processes, we can operate in order from top to next. In this way, it is easy for students to make a memory. A wall joint processing first. The wall joint treatment obviously enters the wall joint between our 2 wall panels. And the stuffed items are insulation boards, which are still the same as 2 sides. We have to first carry out the raw material library. Select the corresponding insulation board. Get the insulation board. We can get a little more. Click this wall seam to paste the insulation material. So we can see that our wall joint treatment is complete. Then we will deal with the steel bars below. The reinforcement treatment is mainly a treatment of the lower connecting reinforcement below. We choose the corresponding tools for steel processing, including ruler, wrench, steel brush, our broom. If you don't know much about software, including our process, you can click on the steel bar to see that. These are all the processes. And we can more easily remember the tools corresponding to each process. You can form a mind map in your mind. Let's deal with steel bars first. What processes are included in steel bar treatment? Including steel, rust removal, and vertical inspection. Verticality adjustment, thread processing, and joint installation of 5 processes. This will also help everyone's memory. We still have tools that have not been received, and raw materials that have not been received. It is a connecting joint of the steel bar. Let's click on the steel bar to remove the rust on the steel bar. Click the steel bar again to check the verticality of the steel bar. Then, you should pay attention to this place of the steel bar. We must use some problematic steel bar for the steel bar adjustment, and then adjust it. If you talk about this rebar that has no problems, it will not trigger an adjustment command. For example, we click on the problematic steel bar and adjust the verticality of the steel bar. Let's do a thread treatment below. Click on it. You can click on any steel bar at this time. Thread treatment. After we finish our processing below, click on the rebar to install the joint. At this time, students can also find out that we are teaching some textbooks and some norms. You can see our rebar connection joints. Shouldn't the connector be staggered? Shouldn't be on the same level, right? In fact, in our steel bar connection specification, it is written that the threaded connection of our steel bar belongs to the first level connection, which can be on the same level. As an expanded knowledge, you can know about it. Let's do a joint surface treatment below. To deal with the joint surface, we can also click the joint surface first. Take a look at our joint surface treatment that originally required chiseled hair. 3 small tools for cleaning rough surfaces and measuring and laying out lines. We can choose the corresponding tool. Your tools for chiseling. The tool stacking area has reached the line. Our stacking area is also the largest one, with a capacity of 6. Like me, I have already ordered too many. We need to remove the corresponding tools. A broom. Click on our bonding surface. Do a chisel. Point the joint surface again to clean the rough surface. We are going to connect a steel bar next. Then the above 3 processes have been completed. Rebar connection. First of all, our steel bar connection. We have to determine that it uses several kinds of steel bars. Then we have to open the drawing and take a look at the back pouring end. This is our post-pour section. Take a look at the steel bar schedule. There are only 2 types of steel bars, type 1 and type 2. That is, our vertical tendons and horizontal tendons. Then we need to get the steel bar first. Open the raw material library. Click on the reinforcement. Open the drawing. And look at a parameter of the steel bar. Get the first type of rebar. Rebar diameter 10 with 12. That is to say, the diameter of the rebar is 12. The size of the tertiary steel 1+B400 rebar can also be calculated. The number of steel bars is 10. You can see that we have received it. Take the second reinforcing bar, horizontal bar. Rebar, diameter C8, 200. Rebar, diameter 8. Reinforcing bar grade, HRB 400, 1 reinforcing bar. The number of roots is not reflected in the schedule. We're going to count on the drawings. You can see 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 horizontal ribs. There is one more dimension, ABC. A is 114, B is 530, C, its diameter is 8. 5 times 8 equals 40. Then it's done. Everyone must pay attention when arranging the steel bars. We have to lay out the horizontal bars first, and then arrange the vertical reinforcement. For example, we first click on this horizontal rib. Horizontal reinforcement arrangement, the spacing we have just said, it is at 200, which is also given on the drawings. And then click on the vertical reinforcement, and we can connect it. After the vertical steel bars are arranged, our steel bar arrangement is completed. But after the steel bars are arranged, they all need to be bound, so we say we need to do another binding. Select the binding tool in raw material website. We use the hook, wire. Click on our steel mesh. Click on our wire mesh. Click to bind the connection. In addition, we also need to use another steel bar after the binding is completed. We also need to carry out a steel protection layer. For setting, it means that we have to choose such a raw material. That is, the protective layer clip. We can choose a little more. And the protective layer is arranged here. Well, if we have steel bars on our side, it is basically completed. But there is still a step, as steel bars belong to hidden engineering. So hidden work layout has been completed. When the construction has been completed, do we need to find a supervisor for acceptance? So we need a step. Select the steel tape measure. Click on our steel mesh block. A touch. It's reinforced concealment, project acceptance of the order. In this way, our reinforcement connection has been completed. We will carry out a measurement of the wire. The measurement of the wire so that we want to choose an ink fountains. Still triggering us to measure the line below the command. After we measure and lay out the line, we need to process a template. But before the template processing, there is a small process that students are more likely to miss. That is, we have to paste the anti-leakage tape on both sides. Let's say we open the raw material library. Choose one of our rubber and plastic tampons. This rubber plastic cotton sliver is used for this side leakage prevention strip. Click on the wall. Paste the anti-leakage tape. We need to process a template processing. First, choose the template. We must first determine the post-pouring section of our construction. Is it an L-shaped or straight-line pouring section? Or a trapezoidal post-pouring section? I'm going to judge it now that it's obvious we're a one-line post-pour, right? For example, we can use the first template type. Enter 300 at the A end, then 600 at the middle end, and then 300 at the end, and click to receive. At this time, a model of our template has appeared in our scene. A model of this template. We need to perform a process on the template. Everyone also knows that. The main thing for our template processing is to perform a demo lighting process on its data. We are going to paint the mold release agent for the steamed buns. And we will clean up the raw material warehouse tomorrow. We will receive the corresponding mold release agent in the raw material library. Get a paint roller, roller brush. Click on our template to trigger the command to paint the release agent. With this, template processing is complete. Then it is necessary to install the template. This model block also needs to use the pull bolt. There is also a fix for our back. We click this template to trigger the template assembly. Click the installation of the pull bolt again, and then click the installation of the back corrugation, and then fix the pull bolts. At the same time, the template project is also a hidden project, and we also need to conduct an acceptance check on it. Not to mention the tool we need to choose the corresponding tool for acceptance. The main tool is the tape measure. Click on it. The template concealment project is accepted. The acceptance of the formwork concealment project is mainly to accept its installation location, including its firmness. We are going to carry out a concrete pouring. Concrete pouring first requires students, according to the dimensions on drawings, to calculate the amount of one concrete. We have already given the length, width, and height here. It is enough to calculate its volume. I will not give you the calculation. You can do a calculation offline. Let's roughly choose one here first. Five cubic. You can see that there is one place that everyone easily misses in this place. which is a sprinkler and moisturizing. We do a sprinkler wetting before we request the pump truck. Then pouring, that is to say. First, click on the tool library to select a watering can for watering and moisturizing. The sprinkler is wet. The tool is wrong. If this place it is not suitable for us to water the can, and we also need a water pipe. Click the water pipe and sprinkle water to moisten it. There is another place that we need to pay attention to before pouring, and it is also a process that we are particularly prone to miss. We need to measure the temperature before bidding to determine whether it belongs to a state of winter construction. So let's open our tool library. Get the thermometer. Click on the thermometer. The temperature measures 24 degrees Celsius, a normal temperature value which does not belong to winter construction. Only at this time can we request the pump truck and template, and request the pump truck. The pump truck has already appeared in our scene at this time. Click on the pump pipe to add concrete. There is a principle for the pouring of our post-pouring section. The principle is a layered pour. The height of each layer of our pouring should be controlled at 500 millimeters. Then, each time the layered vibration is controlled in 20 seconds. So we have to choose one of our vibrators first. Click on the pump tube to trigger a layered pour and start pouring. After pouring, everyone should keep an eye on this value. Do not exceed 500, generally controlled between 400 to 500. Trigger one of shake orders. Start vibrating. If you vibrate, it must be more than 20 seconds. Click on the pump tube. Pour it. And repeat our steps. Let's shake things up again. If everyone is pouring to the end, when there's a little bit left, don't take it lightly. Be sure to keep an eye on it too, and make sure its pour value is controlled at 500. Then the value of the vibration is greater than or equal to 20, so that you can pour it several times. But you must control this value. We shouldn't have 500 left. Just pour it all at once. It should be vibrated. We can see here that the last process is left, watering and curing. And before we sprinkle water for maintenance, our classmates can also know by referring to our traditional buildings. Before maintenance, we must first plaster the surface, and we have to choose one of our plastering tools. the trowel. Click on our template to trigger a wipe command. Click on the wall panel again for a sprinkler maintenance. We can see the progress of the process, so that all the processes of our cast-in-place module have been completed. And then we finish the next one. Then the beginning is the preparation before construction. It's our work done. You first confirm whether the tools and raw materials are all returned, and then click on the completion of the work to clear, and click all the tools and raw materials on the garbage for your confirmation. Click Submit.
The above is the explanation of the knowledge points in this subsection, and I wish you a happy learning journey in the process of learning the prefabricated concrete building construction course.